what would be the real-time use cases for using Hadoop, and what is Hadoop, and what all the differences between Hadoop and RDBMS. So what are the pros and cons between Hadoop and RDBMS, and what would be the job market. So most of in this session will be covering up to Hadoop. So the real-time use cases, big data, and Hadoop will be covering up in this section. So what do you think, what is big data? What is big data in your terms? You might heard of big data in your day-to-day lives. So can you tell me about big data in your perspective? What was it? So that I can have a basic understanding of your levels. Sharada, Gopi?
Big data is the large volumes of data which was highly unstructured or structured.
Okay.
In companies, actually I have classes in business analytics,
Okay.
so that we can use them to do predictive analysis and all that stuff.
Okay. You might have done with the huge volumes of data, right?
Yeah.
Yes.
Okay. And what about you, Sharda?
Yeah, big data means it's a large amount of complex data.
Okay.
You know, it is used
So
for
it,
sharing.
okay, that's fine. Okay, normally whenever you are talking about big data, it can be in the volume. Most of the people will be thinking about the volume thing. It will be the bigger thing. What all the data will be more than what we are expecting, like in terabytes or exabytes, petabytes or so. So normally the thing is that from starting of the computers dawn of the time till some of the time till 2003, there was no such kind of data revolution. Only the data was like only KBs itself, or even the processing speed was in the KBs itself at the point of time. So later on, when it was like from past 4 or 5 years, it's been expanding like exponentially from what we are expecting from the dawn of the time. So it's mainly increasing more because like most of the companies are producing data and they want to use that data as well for that. Earlier, it was in the time like once they produce the data, they were using that for putting on for just like only they are storing data for some kind of a data storage itself in case of any disaster recovery kind of thing. But in the right now with the use of Hadoop or else the other ecosystems which can deal with big data as well, they want to leverage with the big data and can able to get the insightful insights from all the just like Gopi has told us. So it's like predictive analytics and all the other platforms also coming into picture right now. So now at this present point of time, it was increasing in exponentially for say in by 2012 it was 2.7 zettabytes. Earlier it was only 5 exabytes. It's been increased like 500 times more than the data. So this is the pace which the data is getting generated, and it's been moving on in the rapid phase. Even nowadays everyone is using mobile and laptops, and everywhere we are going for social networking or any of the sites, we are generating data. So data is increasing exponentially. It's like right now it's been from 2012 to 15, it's been 3 times what it was like. Means it would be like 9 zettabytes or so, the total data would be. So it's like that much pace. It's everywhere we are getting the data. So data can be taken up for like 3 segments. We can take it up, whether it is a structured data or a semi-structured data or else unstructured data. Most of the cases, whenever you are dealing with structured data, structured means all the tables which you are dealing with, like RDBMS tables and all the CSV, comma separated values, or else Excel sheets, or all of them which are structured, will be taken up in that segment, or semi-structured in the case. You can see that like XML or else JSON format are all semi-structured data. And coming to the unstructured data, you can see what all the data we are considering apart from the structured and semi-structured will be considered as unstructured. And just like even in server logs, even the raw feeds from all the cameras across the some traffic stations or so, anywhere we can able to generate the data right now. So even you can see that in the recent times, even all this all the IoT devices are coming into the market with lots of data generating across. So unstructured big data would be from either from Facebook or else any of the traffic signals or any of the cameras or any of the data. Wherever you go, you can able to find the unstructured data. So to handle such kind of unstructured data, there are no tools like to handle such kind of data in present times. So there is a need for the big data tools to handle such kind of big data. So say for example, if I'm having even in the latest times, an airline jet which would be collecting 10 terabytes of sensor data every 30 minutes of flying time. So it would be, you can able to see the amount of data it's been generating in 30 minutes itself. So it's a very large amount of data. So say for example, in the other cases, even the any of the stock exchanges would be like 1 terabyte of trade information would be generated every day. That means data is generating at a rapid rate. So normally whenever we are talking about structured data, it would be like traditional, or structured data will be in the form of tables, all the other tools. Hello?
Are you saying that airline is one airline? Are you talking about one airline or the whole airline industry?
No,
The previous
a single jet itself, single airline jet will be considering, single airline jet will be, it will be having internally all the sensors, right? It will be checking on the depth of
it is
the
more
present
than
level, which is,
till it is producing more than New York Stock Exchange. One jet.
yes, yes.
Oh, it
So
seems.
new data will be generated in the stock exchange. It's not about the amount of data. It's been like the data which would be, because sensors will be generating all the images, right? So that would be of
Sensors
more of
generated
size.
images.
So even the sensor will be having the images and every data regarding to that. Every second there will be a data generator, right? So there the data will be more than what we are expecting itself.
Okay.
There might be in a jet, it will be like 10,000 or 20,000 sensors will be present in the single jet. So all of them should be responding every second. They will be collecting all the information regarding to the jet.
Okay.
So that is like from the traditional structured data, if we are considering about all the data which is present right now. Earlier we are collecting all of our data into RDBMS systems, which are like MySQL, SQL Server, or DB2, all the Oracle servers. And coming to the unstructured data, it's like all of the other things which are other than structured and semi-structured would be considered as unstructured ones. So you can see this is the present thing, like all the relational data was a kind of a chunk of the data. From 1990s, all the unstructured data started flowing up in the market, like all the application servers, all the other servers which we are handling across. From then, it was like it's been growing rapidly. So apart from this, there is other need also for the big data to handle across, because in normal scenarios, transfer rate of the data is also very critical in there. But in the industry, transfer rate, that means like a seek rate. If I'm taking any of the hard disks, I'm taking it is not increasing as fast as the data is increasing. Data is increasing exponentially here, but the hardware is not uh, sufficing that kind of abilities So we need to have such kind of systems to handle such kind of data, right? So right now what is happening is only single parallel processing or vertical scaling is not uh, able to handle the such kind of big data. So if I'm having right now supercomputers may be having 262 or some GBs of data of RAM 256 plus some of the components which are having. So every organization cannot able to take that kind of investment into their systems. So they are looking for more of a vertical with they don't want to go for vertical scaling, whereas they need to go for horizontal scaling where kind of using the parallel and distributed systems. So say for example, I want to read a 1 terabyte of data from one machine, or else I'm taking 10 machines and doing the same thing, reading 1 terabyte of information. So which would be faster, you would be thinking like. So hello, hello.
The 10 machines?
Yes. So I just want to make sure that this session should be more of a interactive session. I just want it to be. So be pressed so that I can able to give more of my insights also into this session. So you must be more of an directly. You should be more of aggressive kind of thing. You can able to interact everything with me. If any in between anything you have doubts or any of the thing you want to miss out, you don't want to miss, you can able
Okay.
to raise your hand right away.
Hi, can you repeat this for me once more? I'm sorry.
Okay. So I was asking that it should be an interactive kind of thing.
No, the
Okay.
one with about the
Coming.
byte. I mean,
Yep. If I want to read 1 terabyte of data from one machine, and I'm having 10 machines for the same kind of reading 1 terabyte of data, which one would be faster in your case? What would be your thing? So is it one machine will be taking it faster or 10 machines will be taking it faster? That was my question. So obviously it would be the 10 machines, because if say if in my example, if one machine is taking 45 minutes to read 1 terabyte of data from my disk,
then 10
and
minutes.
the
Yeah,
same thing, it would be like 10 minutes only for 10 machines, it would be like only 4.5 minutes it can able to read the
yeah,
entire
yeah.
1 terabyte data. So that would be processed only through the distributed processing system with the parallelism concept. So that's where the main drawbacks for the traditional distributed system. So there are some of the drawbacks in traditional distributed system other than with Hadoop, which is the latest one into the distributed system. The thing is that in normal distributed systems, there will be like node failures will be higher than what we are able to fetch that, and data loss will be the main concept which we need to handle across while we are distributing in the system. So say for example, if I'm having some of the failure of node in my distributed system in an earlier master slave architecture, I need to lose that data in that particular folder. So I don't have such kind of replication factor which is available in the recent systems. So network bandwidth was one of the issue, and scalability problems. They cannot able to scale up to the level of parallelism because master cannot able to support certain point of nodes. It cannot able to scale up to that. So these are all the factors which were the drawbacks in the traditional distributed system, just like the parallel system also. But earlier in the traditional distributed systems, it's like master slave architecture. So
Excuse me.
all the master, yes,
Previously, you said that there is vertical line and horizontal way of doing
yes,
this thing, right? What is the
yes.
difference between those two?
Okay. Coming to the vertical and parallel scaling, that would be like, say for example, I'm having any file right now. So I can able to have a Vertical scaling in the sense the full configuration ability of the machine. Say supercomputer is the vertical scaling I'm talking about. Okay, I cannot able to extend that supercomputer up to a after that after a certain point of time, right? So in a single machine I'm talking about, I can able to scale up to a particular level, but after that I cannot able to scale in the vertical level, right?
Increasing capacity.
Yes, but say for example, if I'm having a single system, or else take your laptop or so, you might be,
Yeah.
it can able to handle up to 2 or 4 slots of disk space itself. But apart from that, if you are going beyond that, it cannot able to support that, right?
Yes.
Yes, in that
The
same
other way
way,
is
vertical.
computers.
The
The
other
other way is
way is like,
connecting all the computers to in parallel.
yes, that is the horizontal scaling apart from the vertical scaling. You understand my point, right?
Yeah, yeah, I got it right now.
Okay. So in the traditional distributed systems, when I'm talking about the horizontal scaling as well, in the traditional distributed systems, these are all the drawbacks which we are facing. So node failures, data loss when there is any kind of node failures. Node failure in the sense a machine in that particular system, if it is fail, means the data in that present across in that node will be lost. So that's the case between. So these two will be related across node failure and data loss. And also network bandwidth issues were there in the traditional distributed system. To handle such kind of drawbacks, we were there with Hadoop. So Hadoop is one system which can able to handle all the parallel processing with also it can able to scale to n number of nodes. So these are all the other features. So there is an answer for all the drawbacks in RDBMS as well as in the traditional distributed system. Hadoop is one of the solution for that to handle such kind of requests. So Hadoop was like it was Dow Cutting was the creator of Hadoop. So he has taken Google file system papers across and he has developed a project called Hadoop, which was part of the Apache project right now. So we can able to find out that in Apache distribution, which is the open source distribution for all the open source softwares. So he it was like it was part of the Apache Lucene project later, which was moved up into Hadoop. It became its own distribution of Apache Hadoop. So this was the total thing. Like 2002, it was started. 2004, Google gave its distributed its file system papers across in the market, and then in 2005 they have given the MapReduce paper as well to the open source community. So Hadoop was separated from the Notch and then becomes as an Apache project. It was a separate project right now. So whenever we are dealing with Hadoop
Hello?
characteristics, hello,
Is Hadoop open source?
yes, it is. Hadoop is open source. That's the reason one of the all the clients which are needing with the commodity software itself, everyone is looking for Hadoop itself.
Okay.
So whenever we are dealing with Hadoop characteristics, we need to check with 3 V's, which is volume, velocity, and verity. These are the 3 V's which we need to consider across when we are dealing with Hadoop. So volume is one thing which you have already told me that there will be n petabytes of data I'll be handling across. So we are getting volume of variety. So as Gopi has told, it's what is big data means it's like very large amount of data that would be considering the volume. So the big data can also be treated with all the 3 V's. So whenever I'm telling about big data, it can be all the three B's. Say for example, I'm having only 1 GB of file which I'm getting, but I'm getting it in a pace like every 1 second I'm getting a 1 GB file. Then is it a big data? Yes, right? But if I'm considering the volume of the data, it is only 1 GB, then if I'm thinking that is not big data, it is not the case. Based upon the type of it, we need to decide on whether it is the big data or not. If I'm getting the certain amount of volume, if I'm getting high amount of volumes in my data, it could be like petabytes or exabytes or terabytes, then we can able to treat it as one kind of big data. In the sense we are taking that as volume. But if I'm taking that like velocity, just like in the case of real-time streaming protocols, like I'm getting real-time some amount of data, but at certain point of time it will be more of a big data. Every second I'm getting 1 GB of file. Then that can also be taken as a big data itself, because it is having that velocity concept. So the other thing is variety of data. So I've already told you about the varieties which are present in the data. It would be like structured, unstructured, and semi-structured. So in case like structured and unstructured, we at present case, even with the certain amount of volumes, we can able to deal with the structured data with all the RDBMS which are handling it. But it comes with the main drawback, like it will be taking more time than what we are expecting. That we can able to relate that to our earlier systems whenever we are going for any of the banks or any of the cases. If you want to go for there, and if I ask for any of the 4 to 5 years of my data, user data, so they would be taking 1 or 2 days earlier. Like they need to go and check with their warehouses and then implement that logic, and then whatever the SQL queries will be returning for, it will be taking 1 or 2 days to get the result for that. Say that's the reason. And early in sometime 4 or 5 years before, if we want any kind of data for 4 to 5 years, the previous data, they're gonna take time for that. So, but to handle such kind of high amount of queries, or else in the warehouse environment as well, we can able to use Hadoop to make that like from days to it can be in minutes. We can able to get the information what we are needed for that. So the main features for Hadoop, these are all the key features. Like it's an open source. As I told you, it is part of the Apache Foundation. So it's an open source. We can able to get the source code and everything for the Hadoop distribution on the Apache site. It's a completely open source and it's a distributed technology. So all across, it's not in a single machine. We can use with a number of machines across, adding all into this into a cluster, so that it is a distributed system. And also it's a batch processing. It's not into the real time, it's into the batch time. So one by one in the batches, it will be able to process all the things. And also one of the main key feature and advantages of using Hadoop, that's the reason all the companies and all the organizations are going for Hadoop, because it can able to handle with commodity hardware itself. That means normal general servers which we are using for all our things, we can able to use with the same configurations. We can able to build a cluster to handle even terabytes of data also we can able to handle with the small machines itself. Other than going for single vertical scaling, like some n number of supercomputers or so, we can able to build some of the system to handle such kind of big data also using simple commodity hardware itself. So, and the main other feature would be like it is a scalable architecture. So we can add up to n number of nodes. We can add 1,000 or 2,000 nodes into the same machine into the same cluster, so that everything will be treated as data itself, and you can able to uh, query on top of that particular amount, 100 or 1,000 node cluster also. So, and the other key feature is fault tolerant. Hadoop is very much fault tolerant, because fault tolerant in the sense, if at any point of time you might, in my earlier slides, I have discussed about the drawbacks of the distributed systems. So main drawback was node failures. In the same case, in Hadoop also, if we are having a 1,000 node or 100 node cluster, there might be node failures, but we will not lose the data in here in Hadoop, because there is a mechanism called which will be looking across with to check on with node failures and able to fix that kind of data replication factor. There is a replication factor in Hadoop,
What's
so
the meaning
that
of cluster?
cluster is a collection of all the machines. Say if I'm having 100 machines, so I'm making it as a cluster. So I'm combining it and making it as a single entity called cluster.
Okay, it's like combining different data, you're combining different machines.
Yes, combining different machines and
And
also with data.
node,
Node is the same thing. Machine is, whenever I'm talking about node, means it is the machine itself. A server, you can able to take it as server.
okay, okay,
So if I'm calling about fault tolerant, if at any point of time, if my node is getting failed or my machine is getting failed, so in my earlier system, it was like I need to lose that data. Once, if that particular node is up itself, then I can able to get my data online. Otherwise, I would be losing my data if any kind of node failures occur. But in Hadoop, the fault tolerance was very much handled across. So if at any point of time there is any kind of machine failure or node failures, we can able to handle, the data should be online, and we can able to fetch the data even there is any kind of failures across in the nodes, and also the data will be high available. That is one of the other features of Hadoop. So at any point of time, if my node is failing also, my data will be available in the Hadoop cluster. So that will be like using, sorry?
Is it achieved?
So it's achieved using the replication factor. I'll be telling you in my next classes like what is the replication factor. I'll give you a basic idea of replication. Say for example, I'm having a data like one GB of data I'm having.
Okay.
So I'm having that in a single machine itself. So if at any point of time, if that machine is failing, I'll be losing that 1 GB of data, right?
Okay.
So the main thing is that distributed system, we are taking this 1 GB file and we are dividing that into blocks. We are like in Hadoop, everything will be in blocks itself. So we are dividing that into blocks and we are distributing that across, say for example, 10 node. So I'm putting that in 10 nodes and also with replication factor of 3. Say for example, for every block I'm taking, so I have divided 1 GB of file into 10 blocks. That means 100 MB I am taking for every block, right? So I'm taking 3 of these copies. I will take every block and I will take the 3
Okay.
copies and I will distribute across in my system. So this is like so at any point of time, if my single node, say for example in that 10 node cluster, one node is down, even then my all of the data will be available. All the 1 GB I can able to fetch that from the other nodes, right?
Yeah.
This is the main thing. Even in case of failure, we are getting the data. and the data will be higher. That's how these two concepts are covered in Hadoop. Fault tolerant
But there
and
will be
high
a lot of
availability.
redundancy, right?
Sorry?
But there will be a lot of redundancy.
Yes, redundancy is the main thing which can able to handle. In the cluster environment, across, if say for example, in my organization or so, companies are not looking on for the redundancy. They are okay for the redundancy thing, but they need the data should be available and can able to get the data results even faster than what they are expecting from the distributed systems or else from the RDBMS systems. So this is one of the other features which is there in Hadoop. Like earlier in any of the distributed system, there was only like we are moving only the data. So slaves will be handling only the data part of it, and all the computation will be taken care by the master itself. So it's a bottleneck, like only that we are using the data part of the slave nodes, but not the computation part of it. But in Hadoop, every node will have its own computation, and the cluster will be working across with that particular computation ability of that particular machine also, and also with the data. So both ways we are using the full-fledged, even the server we are using full-fledgedly to all our computation ability. So it's like more of distributed system right now. This is about all the Apache Hadoop ecosystem. It will be like, you are able to see this, right?
Yes.
This is how the Hadoop ecosystem will be looking like. So on the top, on the bottom of this, it would be like HDFS, which is a Hadoop distributed file system. On top of it, MapReduce, which is the processing thing. Like we need to write all the MapReduce jobs to run any of the thing to run on HDFS. And also Uzi, which is a workflow engine, and also Pix. These are all the other tools which I have told you in data analyst. If you want to go for data analyst, there we'll be handling across with Uzi, Pig, Hive, and some of the tools like Scoop and Zookeeper. With the basic concepts of HDFS and MapReduce, we'll be dealing with. But if we are going for any of the developer sessions, it would be more on the MapReduce will be covered mostly with the whole end-to-end Java code, with also some of the basics of Hive, Pig, and all the other ecosystems. So these are all the ecosystems present in the Hadoop. Hadoop is like it's a framework. Whenever if someone asks for what is Hadoop means, you can able to tell it as a framework consisting of different ecosystems to handle different kind of requests. So these are all we'll be dealing with all of these in our next sessions going forward. One by one we'll be dealing with, and we'll be going deeper into them so that we'll have I just want to make sure that these are all the systems which you will be getting aware of so that you'll be more comfortable working on in our next sessions. So apart from this Hadoop flavors, we are having like more of Hadoop flavors, like Cloudera is one of the major distribution which is available in Hadoop. So these are all the flavors which are apart from Apache distribution. Say for example, I'm having open source distribution, but I'll be having other distributions like Cloudera. These are all the third-party vendors which will be taking all the Hadoop Apache open source distribution and adding some of their own libraries into it so that it would be more of a to additional features of it.
Is it like different versions of Hadoop?
No, it will be the same version of open source distribution itself,
Different implementation.
but on top of it, they will be providing you extra tools as well to leverage with the Hadoop ecosystem. Whereas you will not be getting those tools with the open source community thing.
Okay.
Just like manager monitoring of your cluster, such kind of tools, they will be extra and they will be providing you extra. So
Okay.
there are different kind of distributions across in Hadoop, like Cloudera, Hortonworks, MapR, IBM Big Insights, HP, Haven, and these are all the flavors of Hadoop. Whenever you are talking with Hadoop flavors, you can able to tell them these are all the flavors.
Which one
Apart from
is
this, sorry,
which one is used
in
most?
our course, Cloudera is the top on user perspective because that is the first one which started with Hadoop with the open source community. Later all Hortonworks, Mapper and came later itself. So from right now, from the beginning, it was in the market, Cloudera.
Okay.
So even in our classes going forward, we'll be dealing with the Cloudera distribution itself. So it will be more kind of easier for you to go into market. It's like most of the companies and the organization are going for Cloudera itself. So we'll be dealing with the Cloudera itself in our sessions. These are all the other distributions across in Hadoop, like 1010 Data Action, Amazon Web Services, Hortonworks, MapR, Pivotal, even Teradata has its own distribution of Hadoop. And Microsoft, you might heard of Microsoft Azure, that is part of big data implementation. They have started with Azure concept. So right now it's like the demand for big data is increasing more often. So these are all some of the other places where you can, in India, it will be like you'll be handling across. So it's more of the job market is trending towards Hadoop ecosystems. And everyone is looking on for Hadoop because it's an open source and with the general commodity hardware itself, they can able to leverage with the any amount of data. So they want to build insights on top of their data available across in their system, which they are not using right from the beginning.
The
Okay,
percentage,
any questions?
the percentage,
Yeah,
what are the percentages
sorry,
in the next
percentages
percentage?
in what perspective?
Next slide. Next slide. Yeah.
So these are all the percentage of a demand. So this is the demand between all the cities in just like Hyderabad, or
Out of
demand
all
has
the
been increasing for big data. Sorry?
total jobs,
Yes. This section.
uh, can we have these slides?
No, actually, yes,
Sorry.
Can we have these slides to go through them?
Actually, I'll share with you once our class commences, and I can able to share with you some of the
Okay.
basic slides on top.
Okay.
Okay. If you can able to check with Mahesh or else with Satya on next classes and the availability on that. This
I
will
have a
be the
question.
basic.
Actually,
Yes.
you told me there is two kind of, right, Hadoop development, and what is the other thing that is not related to developing? Like, I don't want, is there something,
Analyst, data
analyst, what,
analyst.
okay, data analyst, and what is it related to? I mean, data analyst related to Oracle
So
using
most of the
SQL.
thing, no, a SQL type kind of thing, and also with basic all the, because normally it will be like whenever you are dealing with analyst, it would be more of a BI you will be handling across, because uh, most of the tools we will be using for the BI tools like Hive will be just like SQL like language, and then you should be what all the data you are getting, you can able to do that in some of the BI components like even Teradata or else some of the BI tools like OBIE,
Okay.
and also with ClickView or Tableau, all
So how
the
do you use Hadoop
even
in as a data analyst? Like what is the relation? I mean, I know Hadoop as a
so you'll
development.
be so it's like Hadoop. You will be working even as a developer. You can able to work on top of Hadoop, or else so it's like different kind of thing. If I'm having Hadoop as a whole system, say I'm like having if I want to add nodes or else check on with the infrastructure part of Hadoop, it would be more considering under Hadoop administration. So administering of all the clusters, monitoring across that, that would be under the administration part of it. But if I'm developing some of the MapReduce jobs and some of the new jobs which I need to go with my company, I'll be going with the development. But once I develop my jobs and I got some output from that, say if I've got some of the data I'm present in my Hadoop.
Mm-hmm.
So I want to query that and I want to get the information from that. I need a data analyst for that to get that kind of information and to uh, give that to management kind of thing, like just like reports generation. That kind of will be the different apart from the development. That will be considered as a data analyst. So you
Okay.
will be analyzing all the data and will be showcasing that in the reports using some
Okay.
of the
Okay.
other BI tools as well.
Okay.
These are all the three areas which we'll be working across in Hadoop.
Okay.
You got it right?
Yeah. Yeah. Yeah.
So right now you will be having a better understanding of the different cases so that you can able to get to,
Sure. Sure.
yeah. You can able to reach out to Satya or else with Mahesh. So,
Okay.
so once we get any of the sessions, we'll be dealing with the next sessions. Tomorrow it would be like more of 10 to 11. I'll be taking the sessions.